Hi, my name is Amir Luqman.
Hi, my name is Ahmad Farhan.
Hi, my name is Nur Izwani Jimat. Hi, my name is Nur Emilia Husna.
Enjoy this video.
Question number 1. This is the diagram that we can get from the question. The feed of the reactor is given is 75%. So when we convert to fraction, will be 0.75. So it means for oxygen is 0.25. So, and after that we get the clue, which is a single pass conversion of the ethylene is 20%. So the first thing we need to do is we need to calculate all the mole fraction for each fresh feed. For ethylene, we get 75 kmol per hour. How we get this? We get from the question, state that the mole flow rate, the total mole flow rate is from here is 100 kmol per hour. So we use that clue to find each of the component, each of the element for the fresh feed. After that, we need to calculate the fractional conversion. This is the formula that we use when we calculate the fractional conversion. Okay, the fractional conversion given here is 20%, and when we convert to fraction, it will be 0.2. So we get the ethylene outlet is 60 kmol per hour. After that, proceed to atomic balance. The rule that we need to know in the atomic balance is inlet equal to outlet. How to calculate the atomic balance is stoichiometry coefficient times with mole flow rate of each component. So for example, C balance. 2 times C ethylene equals to 2 times ethylene outlet plus 2 times ethylene oxide and plus carbon dioxide. So here we put 2 here just because ethylene have 2 coefficient for C, but carbon dioxide doesn't have any coefficient, so we don't need to time with anything. So from the C balance, we get the mole flow rate of ethylene oxide is 13.5 kmol per hour. So for H balance, 4 times ethylene equal to 4 times ethylene outlet plus 4 times ethylene oxide plus 2 times water. So same as C balance, we put 4 here is because for ethylene they have 4 coefficient for H. Same goes to all of here for the outlet. So from here we get the mole flow rate of water is 3 kmol per hour. And O balance, 2 times mole flow rate of oxygen is equal to 2 times of mole flow rate of oxygen outlet and plus with ethylene oxide plus with 2 times carbon dioxide plus with H2O. So from here we got the mole flow rate of oxygen outlet is 13.75 kmol per hour. And lastly, for mole flow rate of fresh feed, how to calculate the mole flow rate of fresh feed? So 100 kmol per hour is equal to fresh feed plus recycle. This is because here from the diagram shows that the total mole flow rate is not from here but here. So here we have a mixture that mix fresh feed with the recycle. So from the mixture to the reactor, the mole flow rate of the mixture to the reactor is 100 kmol per hour, which is this means is 100 kmol per hour is equal to fresh feed plus recycle. So to find the fresh feed, we need to calculate the recycle first. The recycle here is ethylene and oxygen. So we use the information that we get from the calculation. Mole flow rate of ethylene outlet plus mole flow rate of oxygen outlet, which is 60 kmol per hour plus 13.75 kmol per hour, and the answer is 73.75 kmol per hour. To calculate the fresh feed, the total mole flow rate minus with recycle mole flow rate. So 100 kmol per hour minus 73.75 kmol per hour. So we get the answer is 26.25 kmol per hour. So it's done. That's the answer. Thank you.
Okay, for the question number 2, which is the question already given the equation. So we have the 4 unknown, which is N1, N2, N3, and N4. So first we have to draw and label a flowchart of the process. So this is the flowchart of the process, which is the N1, N2, N3, and N4. First, the ratio that are already given, which is 3 mole H2O per 1 mole C2H4O. So we have to calculate the exact value for H2O and C2H4O. So we will get the exact value for feed for H2O, which is 30, and the remaining, which is 10 for C2H4O. So the total feed, which is 40. So we will proceed for number B, which is to calculate the reactor outlet composition using a state of reaction, which is Chi. The already given information, which is the fractional conversion of ethylene, which is 0.92, and the selectivity is 0.85. So as we can see, this is the formula for fractional conversion and the selectivity. So when we put in the formula, we will get the total value for N1, which is 0.8, and the selectivity, which is N desired and undesired. The N undesired, which is N3, and undesired, which is N4. So the value for N3, which is we will get 0.85 and 4. Okay, for the selectivity, the equation is N desired divided by N undesired. For the value for N desired, which is N3, and for the N undesired, which is N4, and the selectivity value, which is 0.85. So we will get the value for N3, which is 0.85 and 4. Okay, continue for question number B, which is we have to calculate the Chi. First, we have to list down all the overall balance, which is for N1, N2, N3, and N4. Okay, for the N1, the value is which is 0.8. So we have just put the value. So 10 minus chi1 minus chi2. So we will get the value for chi1, which is 9.200 plus chi2. And then we have to proceed to value for N3 first. For the value for N3, which is N3 equal to 0.850 N4 minus chi1 plus chi2. So we will get the value for chi2, which is 3.228. And then we will proceed for N2, which is 30 minus chi1. Okay, for value for N3, which is chi1 plus chi2. The value for chi1 we will get from here after we get the chi2. And the value for N4, which is equal to chi2. So we just get the value for chi2 and we will get the value for N4. And finally for the N1, which is 0.8. Finally, for the fraction number C, which is to determine the fractional yield. Okay, for the fractional yield, the formula which is N produced bagi N consumed. The N produced which is C2H2 and the consumed which is also. So the N produced which is value for N3 which is 2.744 and consumed, as we can see, 10 mole. So we have divided by 10. So the value we will get 0.2744. That's it.
Okay, right now we proceed to question number 3. This is figure diagram for the question number 3. Okay, right now we need to use the atomic species balance. Okay, first we use the N balance. Okay, 0.79 nitrogen and times with NO and 2 mole N atomic and 1 mole of nitrogen. So the outlet equal to 0.8405 for the nitrogen from this composition. Next times with N1 and 2 mole N atomic and 1 mole nitrogen. So we will get third equation for the N balance. Next, we proceed to C balance. C balance, we use 100 mole per second for the propane times with 3 mole of carbon atomic and 1 mole per 1 mole propane. The outlet is 0.0957 mole carbon dioxide times with N1 and times with 1 mole carbon per 1 mole carbon dioxide. So from this equation we will find the N1. N1 equal to 3134.7962 mole per second. Okay, after we find the N1, we put the N1 into the equation 1. So from that equation we will find the NO. So the NO is 333.1851 mole per second. So the H balance, we need to find the N2. From the H balance, we put all the data, inlet equal to the outlet from the propane combustion. So we will get the N2 equal to 400 mole per second.
To find the M5, for the filter cake, the formula is M5 equal to 0.95 times M5 plus M6. So we need to find the filter cake first because we want to know the rate of evaporation for question A. After we get the M6, we just need to substitute everything in overall balance that we already did. So first we need to know the overall balance for system, evaporator, for crystallizer and filter. After we get all the overall balance, we need to find the species overall balance for system, evaporator and also for crystallizer and filter. So after we get the results, for filter cake M6 0.05263 M5, we just substitute into to find the value of M5, we need to substitute the value from M6 into species overall balance for system. So for M5, we get 1470.40. After we get the results, the value for M5, we just need to substitute the value into the equation back in M6. 0.05263 times 1470.40, so we get the value for M6 is 77.39. Then we need to do for crystal balance because we want to know every we substitute the value for M5 and M6 for the crystal balance to find the unknown of M4. So we directly can get the value for M7 when we do for water balance equation. So for water balance equation, we can get the value for M7 5645.85, and we substitute by using crystal balance again to find the M4 value here. So we get this value. Then we to find the value for M2, the equation is M1 plus M7, so we get this. Then the rate of evaporation for M3, we just substitute. I substitute the M3 by using balance for this overall balance system, or we can use overall balance system for evaporator or also crystallizer and filter because we already know the unknown value for M4, M6 and also M7. Then the value for M3 is 2952.21 kg per hour. This is the answer for M3 for question A. Then we go to the second question. To find the recycle ratio, mass flow rate of recycle over mass flow rate of fresh feed. The mass flow rate of recycle is known as M7 here. We already know it, and also for the fresh feed is 4500 kg per hour. So we know the value for recycle M7 5645.99 kg per hour. We just divide with M1 4500 kg per hour. So the value of total ratio for recycle is 1.25.